Hello and welcome back to Just Code It. Today we're going to dive deeper into subgraphs and actually create an app that takes in a prompt that is a to-do list item, and then it analyzes it, breaks it into a simple task or a task that needs to be broken down into multiple tasks. Then it prioritizes it and displays it to the screen. Just to start, let's run these two examples. We have remind me to do my homework. That's a simple one. And then plan a trip this weekend, or plan weekend trip. We're going to run it. We're using Ollama. First one is, up here is the first one. The first one is a simple task, correct? And then this is our task. Remind me to do the homework. And then the second one is a complex one. And you can see it broke it down into subtasks. The combined graph that we're creating is this one, but how we're going to break it apart is we're going to componentize this analyze, break down, and simplify, and then also this prioritize functionality within this graph. The first graph is going to be the enrich graph. We'll create it like this, and then the second one is just going to be a linear graph or a chained prompt, and it's just going to prioritize it. Finally, we're going to add them all together to our final graph, which is actually when the main graph displays, it actually displays almost like a LangChain chain or a prompt chain, but in reality, these enrich task and generate reminder are actually subgraphs. Let's go to the top and get going. Let's do our imports and load in our environment variables. I'm using Ollama Gemma 3 and then base and temp set to 0. After that, we're going to create our to-do list state, which has our to-do list, reminder, new to-do is complex, which is a Boolean. All the other ones are strings, and then to-do list is just a list of strings. The operator add adds each to-do list to the previous one instead of overwriting it. The first subgraph node is right here, and as you can see, we have the analyze. I hate how it does that. Analyze, break down, and simple. We're going to start with the analyze. We're going to give it a prompt, give it a system prompt where we're just telling it to analyze the task and define it as either simple or complex and return it. Then we have the human task. Oh, sorry, this is the system message. And then we append the human message task and then add the task. Finally, we're going to invoke using the LLM and give it the prompt. After getting the response, we're going to grab the response content and uppercase the content and see if complex is within that content. If it is, this would be a true value. If it's not in there, it will be a false value, and we will be returning a false value for is complex. I actually decided to change the name of this. It's a bit less of a mouthful. I just changed it to breakdown task. This is the breakdown right here, that node. And what we're going to do is have another system prompt and have it tell the LLM to break down the task into 2 to 3 subtasks. Then we're going to add a human message to that with the task and pass it in. After creating the prompt, we then invoke off of the LLM to actually get the response. Finally, we're going to take that response and grab the content and return it as the to-dos. The last node we're going to work on is pass through simple task. Let's change this one also to simple task. The next node is simple task, which is right here. And what we're going to do is just pass the task straight through. State new to do. Finally, we have our router, or just these edges, the decision edge. And what it's doing is it's returning breakdown if the state is complex or simple otherwise. That is actually how we go on either one of these edges. The next subgraph we have is the prioritization subgraph. Here we're going to prioritize the tasks, essentially just ordering them. First, we're going to check to make sure we have to-dos. If we do, we're then going to combine them all together because remember the to-dos are a list. Then after creating our to-do string, we're going to create a prompt where we're going to grab a system message saying prioritize these tasks. Then the human message is going to be task, and then we're going to pass it the task list string. Finally, we're going to invoke that and return the state variable reminder is set to response.contents. Next, we're just going to create our output node, which is in the main graph, just this display results. I just added this in here. added another dimension to the graph. It's essentially just printing to the screen. You don't need to add this if you don't want. It will just get rid of this last node. After creating all of our nodes, we're then going to create our graph. We're going to start by creating our enrich graph. The graph is going to be created with a to-do state. First off is the analyze, which is set to the method analyze task complexity. Then breakdown, which is breakdown task, and simple, which is simple task. Then we're going to add an edge, which is just this starter edge going from start to analyze. After that, we have a conditional edge where we start from analyze. Then we pass it a method we just created that routes it based on the complexity. And I'm pretty sure we can get rid of this because we have the mapping as the actual node name, but just for practice sake, I would just do breakdown to breakdown and simple to simple. After that, we need to do the edges to the end. Breakdown goes to end and simple goes to end. Like always, we're then going to compile the graph and draw it. And there we have it. The first graph is compiled and ready to go. Now we're going to do the second subgraph. Again, we're going to use the to-do state. We're only going to add one node this time, and it's going to be prioritize task. Then we're just going to add the edge, which is start to prioritize and prioritize to end, compile, and then draw. This is just a chain. Finally, we're going to add everything together. Again, this is just a chain because we extracted the complexity and put most of the complexity in the enrich app. We're going to define our nodes first. Our first node is going to be enrich task, which is going to be set to the subgraph of enrich app. And then we're going to do the generate reminder is set to reminder app. Finally, we're going to just have a normal node where display results is going to be set to that method with the display results, which we did previously. Again, you can get rid of this if you don't want to do it. After that, let's draw some edges. Start to enrich to generate reminder to display result to end. It is just a straight line because we extracted all the complexity and put them into subgraphs. Finally, we're going to compile and draw it. There we have our pretty new graph that looks really simple, even though it's hiding some complexities. Finally, we're going to do our example. Let's just do the first one, simple. You can see it here where it correctly classifies it as a simple task, and then it just gets passed through, and here we have it. Remind me to do my homework. Now let's try the plan weekend trip. This is going to be defined as a complex task, which is no surprise. We are going to go to subgraph 1, breaking it down is complex, prioritize it. We're going to print this is the weekend task. We have all 3 of these subtasks. Within the prioritization, we're going to do a little bit of reordering. It actually doesn't look like it reordered any of it because it probably put it in the right order to begin with. But it did refine it a little bit and create our 3 subtasks that make up our bigger overarching task, which is plan a weekend trip. Finally, we're just coming down and giving some information, help refine what is the trip for, giving some better tips on how to improve the prompt. That is it for subgraphs, or I guess this would be called advanced subgraphs, creating a to-do list optimizer where you're routing your to-do list to either a simple to-do list or a complex to-do list, which will break down into subtasks on the fly. Let me know if you have any questions. Please go to my profile. I have a post up there right now that's a poll, and you can vote on our next topic. Please comment down below if you have any questions. I hope you enjoyed today's video, and I'll see you next time.